Okay, Bismillahirrahmanirrahim. Let's talk about in the last module on the securing the ICS, securing the IIoT data flow or industrial control systems. So in the previous module, we saw on during the OPC and edge deployment, we discussed that there were three different methods to connect edge devices to industrial data. So these are the first one is about the field bus connector running on the edge device, which connects directly to the field devices or controllers. The second about the edge device running on OPC UA client and connected to the central OPC server. The third about the edge device itself acting as client connected to a controller that is running OPC server. So now the main question is how do we secure these setups? So especially in the industrial control system environment. So we'll approach this based on the ICS cybersecurity practices and standards that we just saw, focusing on proper network segregation. This is important. And to do that, we will see where we can introduce the DMZs and where we can place the shared devices like OPC servers or gateways in the isolated zones rather than directly connecting to the corporate network. So this is important thing we will see to place the shared devices like OPC UA servers or gateways in isolated zone rather than directly on the control or corporate network. Okay, rather than directly on control or corporate network. Okay, so this strategy will help us to contain the risk and ensure the secure communication flow. Okay. Okay, so in this architecture, if you see the edge device is directly connected to the control bus, to the PLC and DCS to the control bus, and the protocols may be the feed bus, Modbus or Profibus or control network. So in this setup allows the edge to collect the data directly from the field, and this is powerful. It is powerful, but to secure this environment, we need to use a two firewall strategy. So we need to place the edge in the DMZ zones between the corporate network and the control network, like here. And the first firewall, we are going to use the two firewalls. The first firewall will manage the connection between the edge of to the external corporate network, this one, and then it usually filters the cloud access to the remote clients or plant traffic, and the second will sit between the edge and the control network. So it filters and inspects the traffic to the PLCs and DCs using the this is your deep packet, DIP, deep packet inspection firewall, DPI. Okay. Right. So in this diagram, you can see that how both the data flow and the firewall positions are carefully managed. And this layer approach ensures that even if the edge device is compromised, the the critical control system remains protected because we have a DPI installed here. So this is a standard best practice in uh, industrial cybersecurity, especially edge-based analytics. So this is the standard for the edge-based analytics and cloud connectivity. It's standard and secure best practice. You can say that in industrial cybersecurity, especially when your the edge is taking care, edge for edge based analytics or cloud connectivity. Okay, so to further enhance the security of we are talking about the same architecture, and we will discuss more about this. So to further enhance the security of this architecture, we see that we have seen the DPI firewall, deep packet inspection firewall. So this firewall was placed between the edge device and the control network. We can see it here. It is uh, this is provided between this is between the edge and the control network, and it works like it operates at application layer, and meaning that it just does not look at the header or ports. It actually understands the semantics of the protocol, because this is DPI. For example, what happens is in the Modbus network, for example, in the Modbus control network, DPI firewall can configure the allow only reading operations, or blocking any attempts to the writing attempts to the PLCs and DCS. So this is critical because write commands can alter the system behavior and pose serious risk. Okay, so practically this firewall will drop all uh, Modbus packets, okay, that contains that contain unauthorized function codes, or anything outside the predefined policies. So this is a strong security control that ensures the edge can safely interface with the control layer without compromising the integrity and stability of the control system. Okay, I should write it here that this is a strong security control. This is strong security control, and it ensures that edge can safely interface with control layer without compromising integrity of control devices. Okay. Okay. So now let's talk about the other firewall that completes the DMZ setup. Yeah. So this firewall is responsible for managing the outbound traffic. Specifically, it defines the rules to allow for the HTTPS traffic, which is generated by the edge device towards the external this firewall. external corporate network. However, even with this design, there are two key challenges that we may encounter. The first one is DPI firewall availability is the first challenge, and the second challenge is about the customer policy. So in the DPI firewall availability, not all the DPI firewalls support every not all the DPI firewalls support every industrial protocol. Even if one is available, it might lack the availability or ability to implement all the required filtering rules to secure the traffic effectively. So this makes proper selection of DPI, proper selection is critical. Proper selection of DPI a firewall is critical step. Okay, and okay, so and then the second thing comes, which is the customer policy restriction. And often internal customer policy restricts the use of single edge device for both pulling the data from the control network and pushing it to the cloud or internet. So this dual functionality can be a red flag for IT governance or IT policy. So while the architecture is strong in theory, its success heavily relies on the right firewall capabilities and compliance with the internal security policies. Let me write these points also. So the architecture is strong in theory, but its success relies on right or correct firewall. It should be correct firewall and compliance with internal security policy.